What does the dusty red surface of Mars really hide? Are we on the verge of unlocking the age-old secrets of our mysterious neighbor? Mars is a fascinating world that has aroused our curiosity for centuries. Its gigantic canyons, titanic volcanoes, and icy poles beckon. Beyond these spectacular landscapes may lie clues to an even more captivating history. From traces of ancient water to the enigmatic variations of methane in its atmosphere, Mars never ceases to amaze us. Dear traveler, welcome. Today we're off to explore our red neighbor. But before you set off on your next adventure, be sure to like the video and subscribe to the channel so you don't miss a thing. Thanks, and have a great trip! The planet Mars was spotted very early on, as astronomers in ancient Egypt were already talking about it over 4,000 years ago. The first Chinese writings, at least 1,000 years before the year zero, described the planet's movements. So we've known about it for a long time. But first, let's take a look at the most recent discoveries. Just a few years ago, in March 2024, paleontologist Pascal Lee and his partner, Saurabh Shubham, announced some extraordinary news. They had discovered an immense volcano, over 9,000 meters or 30,000 feet high on Mars. Imagine, higher than Everest. It would extend over 450 kilometers or 280 miles in width. Like all the volcanoes discovered on Mars, it would be extinct and certainly very old. It could therefore bear witness to the planet's history over billions of years. The researchers were surprised that such a volcano had not been discovered earlier. Perhaps this was due to its largely eroded structure, which provided a kind of camouflage. Not all the scientists present were convinced by the discovery. Pending further analysis, the team has given the volcano a provisional name, Noctis. The volcano covers a vast labyrinth of canyons known as Noctis Labyrinthus, the labyrinth of the night, which I'll tell you about later. Although Martian volcanoes are quiet today, the planet was once a hotbed of volcanic activity. Eruptions were numerous, both explosive and effusive, and the volcanoes could be massive. In a moment, you'll discover the famous Olympus Mons, 3 times higher than Everest and so heavy that it's sunken into the planet. Mars' atmosphere is almost entirely transparent, and its surface has been observed continuously by various spacecraft since 1971, when NASA's Mariner 9 space probe arrived. The two scientists were studying a field of deposits left by explosive volcanic activity. They were using maps created over the last 50 years of missions. They saw something that intrigued them. The shape of what would be an eroded volcano, overhung by a pit on a partially collapsed summit, adorned with lava flows, blankets of volcanic ash and minerals, baked by flows of magma-heated water. Its advanced erosion, the stratification of eruptive material, and the fractures visible on its surface have indicated to researchers that this volcano may have formed over 3.7 billion years ago. It would have continued its activity until recently, 10 million years ago. The volcano lies in the middle of an area once covered by glaciers. A site like this, having contained ice and a heat source, could contain traces of past microbial life. This discovery is therefore very interesting, but further evidence is needed to confirm with certainty that Noctis is indeed a volcano. To explore Mars, humans have managed to send spacecraft directly to the planet. I'm going to tell you the story of some of them, who made some wonderful discoveries about the red planet. One of them is called Curiosity, a rover that landed on Mars on August 6, 2012. At 2 meters high, it is much larger than previous rovers. In addition to the dozen or so analysis instruments it is equipped with, it carries a drill to sample Martian rock. It will not depend on solar panels to recharge its batteries, as it uses electrical energy generated by a small nuclear reactor. The aim of the mission is to determine whether the Martian environment could have supported the appearance of life in the past. A rover is a mobile robot that moves over a celestial body. It is also known as an astromobile. It resembles a multi-wheeled quad bike, equipped with probes, lasers, and cameras. The robot moves around, taking samples, performing analyses, and taking photos of the planet's surface. By January 1st, 2023, Curiosity had covered 29 kilometers or 18 miles of Mars' surface. It had analyzed 1,317 samples and transmitted 2,888 results to Earth. Curiosity surveys Gale Crater in the slopes of Mount Sharp. While studying the latest samples taken by the Curiosity robot, an American laboratory discovered the exceptionally high presence of manganese oxide, sometimes up to 45%. And where there's oxidation, there's oxygen. The ChemCam tool analyzes the chemical composition of Martian rocks around the rover. It is equipped with a telescope capable of making remote images with the precision of a microscope. It is also able to focus laser light. This laser sends so much energy onto the rock it touches that it creates a plasma, a small spark, the light from which tells us something about its composition. The manganese rocks discovered at the bottom of the crater have the characteristics of rocks formed in water. They are flat and layered. Unlike the Earth's surface, Mars' surface is not renewed by plate tectonics. As a result, there are vast areas covered by fossil lakes and rivers. Curiosity also discovered salt deposits in sedimentary layers dating back 3.8 to 3.6 billion years. They take the form of hexagons 5 centimeters or 2 inches wide. They resemble the drought-cracked Earth we sometimes see on Earth. They are therefore fossil evidence of an ancient seasonal cycle. Dry and wet seasons alternated on Mars a long time ago. And as you now know, water means life. Independent laboratory experiments allowing molecules to interact at different concentrations and repeatedly have revealed an ideal environment for the formation of complex compounds that make up living organisms, such as RNA. RNAs, for ribonucleic acids, are molecules that carry genetic information. These deposits provide a further clue that life once existed on Mars. By life, of course, we mean bacteria, not Martians. But for manganese oxide to form, oxygen is needed, and right now there isn't any on Mars. Researchers are therefore wondering how much oxygen there was in the planet's primitive atmosphere, and what would have caused the presence of this gas. For the moment, there is no certainty, but scientists suggest that meteorite impacts may have been the cause. These would have increased the level of oxygen in the Martian atmosphere by melting the ice. Manganese oxides take a long time to form, so it seems that there was a lake inside Gale Crater for hundreds, if not thousands of years. We now know that there was water on Mars, as numerous space missions have proved. Curiosity made history a few weeks ago on May 30th. While driving over a shiny rock, he accidentally broke it, revealing yellow crystals inside. By chance, he found sulfur on Mars. Sulfates are quite common on Mars, but this is the first time sulfur has been found in its pure elemental form. Curiosity made this discovery in a place called the Valles Channel. There are many rocks there similar to the one that was crushed, so we can imagine that they too contain sulfur. Sulfur is an essential element for all forms of life. This discovery suggests that there's something very important on the surface of Mars that scientists haven't yet discovered. In any case, these are new avenues to explore. The European space probe Mars Express, launched in 2003, has made major discoveries concerning traces of water on Mars. Since December 2003, the probe has been orbiting the planet, transmitting exciting information. We already knew there was water ice in the planet's polar caps, but in January 2024, researchers announced a major discovery. The probe identified huge ice deposits beneath the Medusae Fossae formation, a region located at the equator of Mars. These deposits are 3.7 kilometers or 2.3 miles thick. They could fill the entire surface of the planet, with an ocean about 2 meters deep, if they were to melt. This is one of the largest water reservoirs found on Mars. For the most optimistic, this reservoir would provide a precious source of water for the first humans to go to Mars. But this layer of ice is covered by a layer of ash and dust several hundred meters thick, which would have to be removed first. Mars Express has been studying the sedimentary deposits on the Medusae Fossae formation for over 15 years. This region of Mars is known as the planet's largest sedimentary deposit. It extends discontinuously over more than 5,000 kilometers or 3,100 miles, covering an area the size of India. It consists of several wind-sculpted geological structures, measuring hundreds of kilometers in diameter and several kilometers in height. These formations are probably the largest source of dust on Mars and one of its most extensive deposits. For many years, scientists were unsure of the composition of these deposits. In 2023, the same researchers once again observed this region of Mars and obtained new data thanks to the Marsis radar. The radar signals match those expected from ice layers. Marsis is the first radar on board a Martian space probe. It is capable of probing the surface of the red planet to depths of several kilometers. The discovery of all this ice answers an essential question that researchers have been asking themselves. What happened to all the water that was on Mars millions of years ago? Since February 2021, another rover has been rolling on Mars in the Jezero crater, Perseverance. The Jezero crater is an interesting place as it is home to a delta that may have formed where water once flowed into a lake. This crater, 49 kilometers or 30 miles in diameter, was certainly caused by the impact of an asteroid 3.7 billion years ago. Perseverance landed on the planet after a journey of some 7 months and 480 million kilometers, or 300 million miles. Working for NASA, the spacecraft collects samples which are sealed in tubes and stored until it's returned to Earth. To carry out these collections, the Astromobile is equipped with a drill and 43 titanium tubes designed to collect cores of Martian rock and soil. By December 2023, 23 of the 43 tubes had already been filled and sealed. They contain sand samples, rock cores, and even air from the Martian atmosphere. After exploring the crater floor, Perseverance headed for the Delta Front. Its journey was made easier thanks to new automatic navigation software, which analyzes photos of the surface and finds the best routes for the robot. The Ingenuity helicopter brought along by Perseverance is also used to prospect the terrain and determine the most interesting places to explore. Perseverance has achieved a small feat, converting Mars' carbon dioxide-rich atmosphere into pure oxygen. It produces 5 grams of oxygen, equivalent to 10 minutes breathing for an astronaut. Wondering how these precious samples are going to get to us? NASA and the European Space Agency are currently preparing the Mars Return Sample mission, which envisages a lander landing on Mars in 2031 to retrieve the samples. Perseverance will have to come to meet it and give it the samples, as the lander will not be able to move around the planet. This is a very stressful project for the researchers, who hope that Perseverance will still be working by then. Plan B is to send small helicopters to retrieve the tubes. In 2024, Perseverance continues its exploration. It has sent photos of an ancient waterway that scientists call the Neretva Valley. It is currently following this valley in a westerly direction. On May 4, 2022, InSight recorded an earthquake on Mars. This Mars quake of magnitude 4.7 lasted 10 hours. The InSight space probe recorded more than 1,300 tremors on the red planet during its mission. It has not been heard from since December 15, 2022, probably due to a lack of energy. By analyzing the seismic waves passing through the bowels of the planet, the mission was able to learn more about its inner layers. Researchers were able to confirm the existence of a liquid core and determine the thickness of the Martian crust. But what happened on May 4, 2022? The earthquake recorded that day caused vibrations to reverberate for several hours. It was called S1222A. Scientists first thought it was caused by a falling meteorite. A crater had to be found to confirm this hypothesis. After several months of searching, it became clear that no new craters had been found. It was therefore concluded that the release of enormous tectonic forces in the planet's interior had caused the earthquake. Mars is therefore much more seismically active than previously thought. The Mars Reconnaissance Orbiter satellite took a nice picture of the surface of Mars in December 2022. A strange geological formation reminded researchers of a teddy bear head. In the photo, you can see a circle forming the perimeter of the face, 2 dots for the eyes and a sort of snout. In reality, the eyes are formed by 2 craters and the muzzle appears to be a gutted hill. A circular fracture surrounds these events and gives the whole thing the appearance of a bear's head. This fracture could be formed by a deposit of lava and mud. The planet was spotted as early as antiquity, but it was Galileo who first observed it through a telescope in 1610. Meanwhile, the Chinese had already calculated the details of the planet's rotation and anticipated its future positions. Arab and Indian astronomers had estimated its size and distance from our planet. Nicholas Copernicus had proposed a heliocentric model for the solar system, in which the planets revolved around the Sun in a circular orbit. Johann Kepler corrected this model, giving Mars an elliptical orbit. Improvements in telescopes in the 19th century made it possible to map Martian albedo formations in greater detail. An albedo formation is an extended region on the surface of a solar system object, distinguished by a marked contrast to neighboring regions. Examples include lighter or darker patches, or expanses of ice. Many astronomers have observed Mars from Earth, but it's only since the 1960s that spacecraft have been sent to or around the planet. Mariner 4, sent by the USA in 1964, made the first flyby of Mars and took the first close-up photos of the planet. In addition to these observations, numerous telescopes located on Earth or in orbit around it carry out remote sensing in wide ranges of the electromagnetic spectrum. Remote sensing is a set of techniques used to determine the properties of natural objects from a distance based on the radiation they emit or reflect. This includes infrared observation to determine surface composition, radio measurements to determine wind speed, and ultraviolet observation to observe atmospheric composition. Among the observers you'll be familiar with is the Hubble Space Telescope, operational since 1990, and responsible for some of the best photos of Mars ever taken from Earth. The Chandra Space Telescope observed X-ray emissions from Mars in 2001. Let's return for a moment to the InSight mission, which I touched on briefly a few moments ago. The objectives of this mission were to determine both the internal structure of Mars and its thermal evolution. InSight is a space probe developed by NASA, which landed on Mars on November 26, 2018, after a 6.5-month journey. It landed in a place called the Elysium Plain. As you'd expect, scientists thought long and hard before agreeing on a landing spot. A failed landing could scupper the whole mission. The probe has to land in a flat, smooth area where it can deploy all its instruments. It also has to be an interesting place to study. InSight is the first mission entirely dedicated to studying the planet's internal structure. Several scientific instruments are on board. A seismometer is responsible for detecting the waves produced during earthquakes and deducing the position of earthquakes and the seismic velocities at which they propagate. It has detected more than 600 seismic events, providing new insights into the planet's surface crust. Another instrument scans the planet's nutation, i.e., the way its axis of rotation oscillates. Another instrument estimates the amount of heat escaping from the red planet. With the exception of the one on May 4, 2022, the earthquakes detected were of low magnitude, 4 at most, but more numerous than expected. The researchers determined that the thickness of the planet's crust is between 24 and 72 kilometers, or between 15 and 45 miles. They noted that the radius of the metallic core is at the upper limit of predictions, at around 1,830 kilometers, or 1,200 miles. The mission revealed an important feature. The thinness of the layer between the core and the mantle is certainly responsible for the planet's rapid cooling. InSight also measured the frequency of meteorite impacts on the surface of Mars. Of the 1,000 earthquakes recorded by InSight, only 4 are attributed to meteorite impacts. The one on December 24, 2021, has enabled us to study the structure of the crust even more closely. InSight stopped giving news after 4 years. The probe still rests in the same place under the Martian dust. The Zhurong Rover is the first Chinese spacecraft to land on another planet. It landed on Utopia Planitia, a wide plain that would have been covered by an ocean. Like the others, this exploration vehicle is in search of water and ancient traces of life. Equipped with 6 wheels, it runs on solar energy. It weighs 240 kilograms or 530 pounds and carries 6 scientific instruments, including cameras, radar, and a weather station. Although the mission was scheduled to last 3 months, it actually took over a year. The rover collected information on the Martian weather and atmosphere, which may be thinner than previously thought. It covered 2,000 meters or 6,500 feet of Martian soil. It discovered evidence of water on Mars not so long ago. But before such craft could explore the Martian surface, tests had to be carried out. The first 2 probes to land on Mars were fixed landers called Viking. They landed in 1976. The aim of this mission was to detect biological activity linked to bacterial life on the planet. They were unable to detect this supposed bacterial life, but they did greatly advance our knowledge of the environment on the surface of Mars. They provided meteorological data for several years, Viking 1 until 1982, and its twin until 1980. A series of failed missions to Mars in the 1980s and 1990s put off further attempts for a long time. The hardest part was landing gently on Mars. Finally, in 1997, NASA sent another small robot, Sojourner. The aim of this mission was to demonstrate that it was possible to control and operate a rover on the planet. The size of a remote-controlled car, Sojourner carried a single scientific instrument and covered only a few dozen meters of the Martian surface. The success of this mission encouraged NASA to continue. This led to the development of the Mars exploration rovers Spirit and Opportunity. These rovers surveyed the Martian surface for several years, starting in 2004. They measured 1.5 meters or 5 feet in height and weighed around 200 kilograms or 440 pounds. Spirit operated in the Gusev crater for 7 years before coming to a halt, as several of its instruments had failed and it could no longer move. Opportunity operated for much longer, spending 15 years in the Terra Meridiana region. It covered more than 45 kilometers or 28 miles, which remains a record. The mission was stopped in 2019 following a dust storm that prevented the solar panels from working and recharging the batteries. But what interesting things did these 2 rovers discover? They discovered sedimentary rocks and salts that show that water has flowed for long periods of time at both sites explored. They also demonstrated the importance of being mobile, as the water discoveries were made far from their landing site. But not everything goes smoothly. The success rate for Mars missions is no more than 50%. Some missions fail altogether, like the Japanese orbiter, Nozomi, which was never able to reach Mars because of an electrical anomaly. The European ExoMars mission was based on the orbiting of the Trace Gas Orbiter satellite and the landing of Schiaparelli. The probe has been operational since 2016, but unfortunately the lander crashed on the surface of Mars. It had time to send technical information about its descent to Mars. This information made it possible to understand why it had crashed, an anomaly in the onboard software. While the rovers continue their explorations, scientists are preparing the next missions. The Europeans plan to send a rover called Rosalind Franklin to Mars in 2028. This mission, known as ExoMars, has had its share of setbacks. First, technical problems prevented the probe from leaving in May 2018, then in July 2020. The probe carrying the rover would normally take off in 2028, landing on Mars in 2030. The probe can only be launched during short launch windows every 26 months. The journey to Mars should take 9 months. The exploration zone will be Oxyaplanum, a detailed geological map of which has been drawn up. Oxyaplanum is a 200-kilometer or 125-mile basin that lies fairly close to Mars' equator. It contains clayey sedimentary deposits that are 4 billion years old, testifying to the past presence of a lake or sea. The objectives are the same as for the other Mars missions. Search for evidence of past or present life. Study the geochemical environment of the surface layers of the Martian subsoil. Study the gases present in the Martian atmosphere. And characterize the environment on the surface of Mars. Perhaps by searching in an unexplored area, the robot will have the chance to find new elements. We can send probes and robots to Mars, but when will we see a human on the red planet? Is there a project underway to send humans there? The most optimistic window of opportunity would be 2033, but a more realistic first manned mission could take advantage of the 2037 launch window. In the meantime, NASA is experimenting with living conditions on Mars. In February 2024, it published an original job offer. It is looking for 4 volunteers to take part in a simulation of life on the red planet. This one-year mission will take place from spring 2025 in a facility created using a 3D printer. Volunteers will be able to live and work in this facility. This experiment is part of the CHAPIA program for Crew Health and Performance Exploring Analog, which will take place in Houston. They will have very specific missions, dealing with a hostile environment, technical problems, limited resources, and extended communication times. Versatility will be required, as they will be involved in robotics, maintenance, exploration, and even agriculture. They won't have time to get bored in the Mars Dune Alpha habitat. As part of the CHAPIA program, a similar experiment has already taken place from June 2023 to July 2024. The 4 scientists have just emerged from their confinement after 378 days. The 2 men and 2 women involved were even able to grow vegetables and partially meet their dietary requirements, notably with fresh produce. They have also simulated walks on Mars. Despite these simulations, not everything can be tested in advance. Gravity on Mars, which is 38% that of Earth, cannot be reproduced. The high levels of radiation present on Mars and during the months-long voyage cannot be simulated, so the risks and efforts on astronauts' health are unknown. Finally, the climatic conditions on Mars cannot be fully reproduced on Earth. For the time being, living conditions on Mars seem very difficult, but some people are proposing solutions. A team of researchers and students from MIT, the Massachusetts Institute of Technology, have imagined how future inhabitants of Mars could live there sustainably. They have imagined huge bubbles called redwood forest. The imagined domes each house a tree responsible for sustaining the ecosystem inside the bubble. Each of these bubbles collects solar energy and uses it to transport water harvested beforehand from the planet's northern plains. Humans move through a network of underground passages linking the bubbles together. This forest could house a community of 10,000 people, with 50 inhabitants per bubble. The tree's roots offer humans protection against cosmic radiation, micrometeorite impact, and extreme thermal variations. The United Arab Emirates had almost the same idea. A city covered by a huge bubble should emerge from the ground to simulate the life we could have on Mars. Paul Smith, the researcher at Bristol University, goes even further. He proposes to recreate a small corner of Earth under a dome. Same idea, you ask? Except that he put a variety of animals and plants inside, including fungi, soil microbes, earthworms, and spiders. As you can see, scientists have no shortage of ideas for making life on Mars possible. But will it be pleasant? One thing's for sure, the next few years will be exciting in terms of exploring the red planet. Now that we've had a look at recent and future Mars exploration, you'd still like me to tell you about its geography, wouldn't you? What's on Mars? What would a Martian globe look like? Are there any sights? Unusual landscapes for us Earthlings? Wondering why Mars is a red planet? To put it simply, it's because it's rusty. Its surface is covered with iron oxide or rust. The Romans called it Mars because of its blood-red color, in honor of the god of war. The Persians saw fire in it and named it after the god of fire. But Mars wasn't red over 3 billion years ago. The planet would have experienced a solar event that blew away its atmosphere. The atmosphere then slowly oxidized the iron-rich soil. Its red color is not uniform, with shades of brown and orange. It can be accentuated by storms that shake the planet, raising clouds of reddish sand, or attenuated when weather conditions are calmer. The Hubble Space Telescope has shown stunning images of the red planet before and during the Great Storm of summer 2021. In the June images, we see a more orange planet with gray patches. In September, after the storm, the planet is as if cleaned up. Its color is much more uniform. Mars' colors also vary with the seasons. In winter, colored dust attaches itself to frozen carbon dioxide particles and falls directly to the ground. This brightens the atmosphere. In summer, unfrozen dust remains suspended in the atmosphere. They are dispersed for longer by surface winds, forming darker or lighter clusters depending on the wind direction. Isn't Mars frozen all year round? Well, no. Temperatures vary, from minus 133 degrees Celsius to plus 27 degrees Celsius, or minus 207 degrees Fahrenheit to plus 80 degrees Fahrenheit. The average temperature on Mars is minus 63 degrees Celsius or minus 81 degrees Fahrenheit. So it's best to go during the day, when temperatures are above 0 degrees Celsius or 32 degrees Fahrenheit. Because when night falls, temperatures drop rapidly, whatever the season. It's so cold that the carbon dioxide in the air sometimes condenses on mountaintops in the form of dry ice. So there are mountains on Mars? I told you about this recent discovery, a huge volcano over 9,000 meters high. It's impressive, but it's nothing compared to Olympus Mons. This enormous volcano peaks at over 21,000 meters or 69,000 feet above sea level. It is the highest known landmark in the solar system. It owes its great size to the fact that over a very long period of time, magma has risen in the same place, building up the mountain. Mars has no tectonic plates that could have moved the mountain during its formation. This explains why Martian mountains are so much bigger than those on Earth. Olympus Mons is a shield volcano, i.e. a volcano characterized by effusive eruptions producing fluid lava flows. It is formed by the superposition of a large number of flows. Its shape evokes that of a shield resting on the ground, a relatively flat cone. The average inclination of its slopes varies between 5 and 10 degrees, with some variations. It has a large crater or caldera at its summit. The mountain's diameter is around 600 kilometers or 370 miles. To give you an idea, its surface area is comparable to that of Italy. It began to form 3 billion years ago. Most of its volume was formed 1 billion years ago, but small lava flows took place only 2 to 5 million years ago. The last lava lakes in its caldera are estimated to be around 100 million years old. Olympus Mons was first called Nix Olympica, snow of Olympus, because of its high reflectivity. Observing it through a telescope, scientists first thought they were looking at eternal snow. In reality, they were white cirrus clouds made up of water vapor and ice, which form at high altitude above the volcano. The volcano is still active, but very weakly. It is thought to have dominated an ocean in the distant past, some 3.8 billion years ago. At the base of the volcano, researchers have identified an escarpment similar to those found on land-based volcanic islands, such as Hawaii or the Azores. This landscape is the result of the encounter between molten lava and the sea. The lava produced by the volcano is undoubtedly basaltic. Only very fluid lava, low in silica and rich in ferromagnesian minerals, can flow down very gentle slopes over tens, even hundreds of kilometers. The same characteristics can be found at the base of another Martian volcano, Alba Mons, some 1,600 kilometers or 990 miles northeast of Olympus Mons. Rock samples would have to be taken from these volcanoes and analyzed to prove the existence of an ocean and determine when it would have existed. But Olympus Mons isn't the only impressive mountain on Mars. This volcano is located on the Tharsis Plateau, 7 kilometers or 4 miles high, which is a vast volcanic bulge over 5,000 kilometers or 3,100 miles in diameter, centered on the Martian equator. At the center of Tharsis are 3 volcanoes perfectly aligned along a fracture in the surface crust: Arsis Mons, Pavonis Mons, and Ascraeus Mons. They are separated from each other by around 700 kilometers or 430 miles. Researchers discovered that the nature of the lava evolved during the formation of the 3 volcanoes. Initially highly viscous, it transformed into the heavier basaltic lava that forms the visible surface of the planet's crust. This has enabled us to deduce the order of formation of these volcanoes. Arsia Mons is the oldest, followed by Pavonis Mons and Ascraeus Mons. The way they came into being is interesting and very different from that of terrestrial volcanoes. On Mars, it was the plume of molten magma from deep in the mantle that moved slowly, piercing the planet's crust in 3 different places. On Earth, chains of volcanoes originate from fixed hotspots over which lithospheric plates slide. These 3 volcanoes are also very high. Ascraeus Mons is 18,000 meters or 59,000 feet high. Pavonis Mons, 14,000 meters or 46,000 feet, and Arsia Mons, 17,000 meters or 56,000 feet. Real giants. And that's not all. Their diameter measures around 400 kilometers or 250 miles. The caldera of Arsia Mons has a diameter of 110 kilometers or 70 miles. By comparison, the caldera of the Hawaiian volcano Mauna Loa measures just 2.7 kilometers or 2 miles in diameter. The alignment of these 3 volcanoes is extended to the north by the Uranus group. This is another massif of 3 volcanoes, located in the Tharsis quadrangle. It includes Uranus Mons, Uranus Tholus, and Soronius Tholus. But Mars didn't just produce shield volcanoes. There are also many much smaller stratovolcanoes and lava plains similar to the volcanic expanses found on the Moon or Mercury. I mentioned the Tharsis Dome, but many volcanoes are also located in a region called Elysium Planitia. This region is smaller than Tharsis. Its diameter is around 3,000 kilometers or 1,900 miles, and its height 4 to 5 kilometers or 3 miles high. The region's most imposing volcano is Elysium Mons, which peaks at around 14,000 meters or 46,000 feet. It is 410 kilometers or 250 miles wide and has a caldera 14 kilometers or 9 miles in diameter. Its slopes range from 1 to 10 degrees. There are two other volcanoes in its vicinity, Hecate's Tholus and Albor Tholus. Apollinaris Mons lies a little further away, on the other side of Elysium Planitia. These volcanoes are more closely related to stratovolcanoes, such as Pinatubo, Mount Pelee, and Vesuvius. A stratovolcano is made up of several strata of hardened lava and tephra, solid rock fragments expelled during the volcano's eruption. But the location of volcanoes on Mars is not limited to these two regions. Other volcanoes of more modest dimensions can be found in different parts of the planet. The smallest volcanoes measure just 5 kilometers or 3 miles in diameter. They are often small volcanic cones aligned on faults or fractures in the Martian crust. There are also volcanoes in the shape of a pancake or inverted saucer, such as the famous Alba Patera. This is a very unusual volcano. It is very wide and located at high latitudes, 50 degrees north latitude. It has two tangled calderas, making it look like an eye surrounded by two eyelids. It measures 1,600 kilometers or 1,000 miles in diameter, and over 6 kilometers or 4 miles in height. Its slopes are very gentle, but there are some gigantic fractures running for several hundred kilometers or miles and up to 2 kilometers or 1 mile wide. There are other volcanoes of the same type on Mars, but much smaller in size. In general, these are very old volcanoes whose surfaces bear the marks of time, erosion, and meteorite impacts. Some of them have practically disappeared under the effect of erosion. They probably date back 2, 3, or even 4 billion years, and are among the oldest buildings on Mars. Mars also has what is known as lowland volcanism. This volcanism is found in the same places as shield volcanoes. Here, the lava has emerged from fissures and flowed over wide expanses, which can be seen as far as the eye can see without any relief. Over 60% of the Martian surface is covered by fluid lava fields. It's hard to put a precise age on Martian volcanoes, but we're pretty sure that the planet's volcanic activity lasted for a very long time and is still going strong. I told you that the biggest volcano in the solar system is on Mars, but the biggest canyon is there too. It's called Valles Marineris. In the photos, it appears huge, like a big rip in the Martian equator. It is thought to have been formed by progressive subsidence along faults, a kind of landslide. Valles Marineris is not a single canyon, but an immense network of canyons incising the planet's crust to a depth of several kilometers. Some researchers believe that the canyon's origin is linked to the existence of plate tectonics on Mars. It was thought that plate tectonics didn't exist on Mars, but perhaps they did a long time ago. The origin of the canyon is still a mystery. One hypothesis is that its formation began when the planet cooled and its crust contracted, creating fractures and crevices on its surface. Volcanism, erosion, and tectonic collapse would then have given it its current shape. The Mariner 9 probe discovered this vast canyon system in 1971. It stretches for some 3,770 kilometers, or 2,340 miles, and can be up to 600 kilometers, or 370 miles wide in places. Its depth can reach 10 kilometers or 6 miles. The interest in this canyon lies not only in its size, but also in its potential to answer key questions about the history of Mars. Throughout its length, it presents a wide variety of features: cliffs, mountains, secondary canyons, and dry riverbeds. But there's another interesting feature of Martian geography, and that's its crustal dichotomy. A strange name to signify the major difference between the northern and southern hemispheres. The northern hemisphere is made up of a vast, smooth plain at an altitude of 6 kilometers below the reference level, while the southern hemisphere is made up of plateaus, craters, and rugged terrain. These two geographic regions are separated by a very clear boundary, slightly oblique to the equator. Between these two hemispheres lie two clearly differentiated volcanic regions. These different types of Martian terrain are linked to three characteristic eras in the planet's geological history: the Noachian, which corresponds to the oldest terrains, from the formation of the planet 4.6 billion years ago down to 3.7 billion years ago. These terrains are mainly located in the southern hemisphere. The Hesperian, which corresponds to terrains from 3.7 to 3.2 billion years ago, marked by strong volcanic activity resulting in lava flows and sulfur deposits. The Amazonian, which corresponds to terrains less than 3.2 billion years old, with very little cratering, and located mainly in the northern hemisphere. Mars, like Earth, has two polar caps. During polar winters, they are plunged into continuous darkness. They consist of a permanent cap, which is covered by a seasonal cap during the winter. The southern cap is 350 kilometers or 210 miles in diameter, and is composed mainly of dry ice, i.e. carbon dioxide. Carbon dioxide sublimates from a solid to a gaseous state. It would appear that this cap is melting. Its main component is water, in the form of ice, but if we study it to a depth of 1 kilometer or 0.6 miles, we also find sand and rock. Now let me show you another Martian curiosity, Noctis labyrinthus. No, it's not a labyrinth, but rather a region populated by a network of deep valleys. It's nestled between the Great Valles Marineris Canyon and the volcanoes of the Tharsis region. It was first observed in the late 19th century by the Italian astronomer Giovanni Schiaparelli. The maze of valleys is the result of intense volcanism in the Tharsis region. It caused a vast area of the Martian crust to bend upwards, stretching it and subjecting it to tectonic stress, leading to thinning, faulting, and subsidence. The photos show gigantic landslides covering the slopes and bottoms of canyons. Other slopes are covered by sand deposited by Martian winds. The largest canyons measure up to 30 kilometers or 19 miles wide, and 6 kilometers or 4 miles deep. This network of valleys stretches for almost 1,190 kilometers, or 745 miles in length, roughly the length of Italy. You don't want to get lost here. We've looked at the surface of Mars and studied its volcanism, but I haven't yet presented the planet in figures. Mars is one of the 8 planets in the solar system. It is 4th from the Sun. It's our next-door neighbor, the planet closest to us after Venus. It lies 220 million kilometers or 135 million miles from the Sun. Earth is 150 million kilometers or 93 million miles from the Sun. We could therefore deduce that Mars is 70 million kilometers or 43 million miles from the Earth, but that would be a beginner's mistake. Since the planets revolve around the Sun, in elliptical orbits they are not always at the same distance from each other. The closest the 2 planets could get would be 54 million kilometers or 33 million miles. The diameter of Mars is 6,794 kilometers or 4,200 miles, almost half that of the Earth. Mars is about 7 times smaller than Earth and 10 times less massive. Its atmosphere is very thin and 60% less dense than that of Earth. It does not retain the heat generated by the Sun, which explains its cold surface temperatures. The Martian atmosphere is 96% carbon dioxide. There are also traces of argon, 1.93%, and nitrogen, 1.89%. During Martian storms, the atmosphere becomes very dusty, but these particles are blown away with a single breath, as gravity on Mars is very weak, 38% of that on Earth. Its revolution time is 687 Earth days, and its rotation time, 24.7 hours. I've already told you that there are 4 seasons on Mars just like on Earth. This is because the inclination of its axis of rotation is almost the same as that of the Earth. It's 23.5 degrees on Earth and 25.2 degrees on Mars. On Mars, on the other hand, winters are short and mild in the north and longer and harsher in the south. Mars is a telluric planet, like Earth, Mercury, and Venus. These planets are located between the Sun and the asteroid belt. They are much smaller than the gaseous planets but have a higher density, as they are composed mainly of iron and silicates. The other planets in the solar system are gaseous. A telluric planet is composed mainly of rock and metal, and generally has 3 concentric envelopes: core, mantle, and crust. Since the InSight mission in 2019, we know with certainty the size of the Martian core radius, between 1,810 and 1,860 kilometers, or between 1,120 and 1,160 miles, half that of the Earth's core. This result implies that Mars' core contains light elements such as oxygen, iron, nickel, or sulfur. Mars has 2 natural satellites, Phobos and Deimos. Phobos is 7 million times less massive than the Moon, while Deimos is almost 50 million times less massive. Phobos orbits less than 6,000 kilometers or 3,700 miles from its planet, and circles it in less than 8 hours. It travels at 7,700 kilometers per hour, or 4,800 miles per hour. It was discovered in 1877. It has a surprising shape and a surface lined with impact craters. The best known is the Stickney crater, with a diameter of 9.5 kilometers or 6 miles. The diameter of Phobos is just 22 kilometers or 14 miles. Within 30 to 50 million years, it will disintegrate in the Martian atmosphere, forming a ring around the planet. It moves closer to Mars by 2 meters or 6 feet every 100 years. The geological formations found on Phobos are named after the astronomers who studied it, but also after characters and places from Gulliver's Travels. Surprising, isn't it? One ridge is named Kepler Dorsum after the astronomer Johann Kepler. Its surface is covered by a layer of loose regolith, a mixture of rock and dust very different from the more solid surfaces of many other moons. Millions of years of meteorite impacts are thought to have ground its surface into a fine dust. These characteristics are unlike those observed on any other moon in the solar system. Their origin is therefore unknown. Some believe they were formed from debris resulting from a giant collision with Mars. Others believe they are captured asteroids. Recent research has shown similarities between Phobos and comets from the Kuiper Belt. If Phobos really did come from the Kuiper Belt, it would change our understanding of the history and evolution of Martian moons. Japan's Martian Moons exploration mission, scheduled for 2026, is set to bring samples back to Earth after 3 years of exploration. Deimos orbits 23,000 kilometers or 14,300 miles from Mars at a speed of 4,800 kilometers per hour or 3,000 miles per hour. Its revolution around Mars lasts 30 hours. Its shape is equally atypical. Its diameter is just 12 kilometers or 8 miles. Unlike Phobos, it is moving away from Mars. Its fate will therefore be less tragic, but it risks disappearing into space. Only 2 craters are known on its surface, Swift and Voltaire. The largest measures 3 kilometers or 2 miles in diameter. Its surface appears smoother than that of Phobos, as it is covered by a thick layer of regolith that could be as much as 100 meters or 330 feet deep. In mythology, the name of these satellites means fear and terror. They don't look very frightening, though. We don't always have to travel far to find samples of other planets. Sometimes they come to us. This is the case with Black Beauty, or NWA 7034, whose fragments were discovered in Morocco in 2011 and 2012. As you may have guessed, it's a shiny black piece of rock. It's a meteorite that made it to Earth. Most of them vaporize in the atmosphere before hitting the ground. We knew it was the oldest Martian meteorite in our possession, but we needed to know which region of the red planet it came from. Anthony Legane, an Australian researcher, succeeded in tracing its origins. The meteorite, which weighs 320 grams, is particularly interesting. It is a breccia, i.e. an agglomerate of different types of rock, older than the formation of the breccia itself. Some of Black Beauty's minerals have been dated at around 4.48 billion years. It is also 10 times richer in water than other Mars samples. It could therefore testify to the presence of an ocean, and therefore of life on Mars, at a time when life was just emerging on Earth. That's why it was so important to determine its site of origin, to make it a future exploration site. Australian researchers have found the place from which it was expelled, the Karratha crater. We now know that it is a witness to the formation process of the primordial crust of Mars. Black Beauty is thought to have escaped Mars' gravitational field between 5 and 10 million years ago, following an impact that propelled it far from the planet. How do you get a glimpse of Mars if you're not lucky enough to travel into space? The best time to observe Mars is every 2 years. The planet is aligned with the Earth and the Sun, in opposition to the Sun. Mars is then visible all night long. The ideal conditions for observing it will occur in January 2025, in just a few months' time. But you can already see it at the end of the night. At opposition, Mars is closest to us, but the distance separating us from it varies. This variation is due to the planet's elliptical orbit and the periods of revolution of Mars and Earth. On January 12, 2025, Mars will be 96 million kilometers or 60 million miles from Earth, but it will be at exact opposition on January 16th. Don't forget these dates, or you'll have to wait until February 2027. If you look at the sky with the naked eye, you'll only see its brightness as it approaches the Moon. If you want to see details of its surface, you'll need an instrument with at least 115 to 130 millimeters of magnification. During the next observation period, you'll be able to see the northern polar cap, as the planet will be showing us its northern hemisphere. You'll also be able to see large characteristic formations, such as Syrtis Major, which appears as a large dark spot. It's a basaltic structure formed by lava outpourings from Syrtis Major, a shield volcano. It is a large volcanic plateau with a diameter of around 1,350 kilometers, or 840 miles, and a height of 1,500 meters, or 5,000 feet. Its highest point, Nili Patera, is 2,000 meters or 6,600 feet above sea level. The solar system began as a large cloud of gas, dust, and ice. This transformed into a rotating disk, from which the Sun was born at its center. The planets formed from the particles that came together. Our Sun is now 4.5 billion years old. Its lifespan is estimated at 11 billion years. At the end of its life, it should swell, leaving only its core behind to become a white dwarf. The planets of the solar system should disappear, blown apart by the Sun's gigantic explosion, unless they are swallowed up by it as it expands. All that will remain is a few scattered pieces of debris, forming a disk around the white dwarf. Mars will disappear at the same time as the Earth, but some researchers believe that it should pull through and remain in orbit around the white dwarf. Mars is close but exciting. Its proximity allows us to study and observe it well, and to send increasingly sophisticated spacecraft there. It seems to have lost almost all its internal geological activity, but it could surprise us. For the moment, we're seeing minor events such as landslides, carbon dioxide geysers in the polar regions, earthquakes, and small lava flows. Like most of us, Mars calms down as it ages. Mars is almost certainly the next planet on which man will set foot. One thing's for sure, though, Mars has a lot to live up to. Why aren't the 4 planets furthest from the Sun solid? Precisely because they're far from the Sun. Solar luminosity has defined 2 distinct zones in the solar system, separated by what is known as the ice line. This imaginary demarcation plays a crucial role in the composition and formation of the planets, To understand why the 4 planets furthest from the Sun, Jupiter, Saturn, Uranus, and Neptune, are not solid, it's essential to delve into the mechanisms of planetary formation and the influence of distance from the Sun. The ice line, also known as the frost line, marks the boundary in the protoplanetary disk. This is a disk of gas and dust that surrounds a young star during the formation of a star system. Beyond this boundary, the temperature is low enough for volatile compounds such as water, methane, ammonia, and carbon dioxide to condense into ice. This line is generally located at a distance where the temperature falls below about minus 123 degrees Celsius or minus 190 degrees Fahrenheit, allowing these compounds to change from a gaseous to a solid state. The exact position of the ice line can vary according to the luminosity of the central star and other local factors within the protoplanetary disk. In our solar system, it is located at around 5 AU, or 5 times the distance from the Earth to the Sun. Inside the ice line, warmer conditions prevent the formation of ice, limiting the materials available to refractory compounds such as silicates and metals. These materials form grains that gradually aggregate to create planetesimals and eventually telluric planets with solid cores. The Earth, Mars, Venus, and Mercury formed in this zone, characterized by rocky surfaces and predominantly solid compositions. Beyond the ice line, on the other hand, the significant drop in temperature allows volatile compounds to condense. This accumulation of ice increases the amount of material available for planetary formation, facilitating the rapid growth of planetary cores. These cores can then attract and retain huge quantities of gas from the protoplanetary disk, forming the massive envelopes of the gas giants. Jupiter and Saturn, with their hydrogen and helium-dominated compositions, formed relatively close to the ice line, effectively capturing these light gases. Further out, Uranus and Neptune, often referred to as ice giants, have compositions that include a greater proportion of frozen, volatile compounds. They were born almost at the same time as the Sun, 4.55 billion years ago, within the same cloud. It all began with a cloud of gas and dust that collapsed under its own weight, forming a disk. The bulk of the matter concentrated in the middle, where the Sun was born. The remaining dust and gas continue to rotate in a particular pattern. The heavier elements remain close to the Sun, in the center of the disk, while the lighter elements move towards the periphery. These light elements are, as you may have guessed, gas and dust. 2 dust particles have met to form a slightly larger one. This is repeated by snowball accretion until baby planets are formed, called protoplanets, which can have 10 times the mass of the Earth. The mass of these protoplanets, made of rock and sometimes ice, begins to attract nearby debris. This debris includes the surrounding gases. The accumulation of these gases increases the mass. The critical mass of the solid core is reached after 8 million years and constitutes around 15 Earth masses. Gas accretion then becomes exponential, and the protoplanet becomes a gas giant. It's this very mass that still enables gas giants to hold these gases around them. The solid core provides the gravitational force needed to hold the gas envelope in place. Without it, the solar winds would have swept the gases away long ago. This so-called solid core explanation is the one that currently prevails for the formation of gas giants. But the debate on the formation of gas planets is still far from settled. A second scenario is that of gravitational instability. Giant planets are formed in the same way as stars. The protoplanetary disk can become gravitationally unstable, collapsing and fragmenting into bodies whose typical mass is of the order of Jupiter. Such a mechanism could produce a Jupiter-mass body in 1,000 years. The latter scenario is unlikely, but not out of the question. Giant planets don't just have gas in common. They all have a ring, even if Saturn's is the most prominent and famous. They also all have satellites. The presence of such planets in a star system has far-reaching consequences. It stabilizes the orbits of all the planets, and they form an effective screen against stellar objects. In this way, the presence of life on Earth has been greatly favored by our four giants, especially the nearest and largest, Jupiter. Jupiter and Saturn are composed mainly of hydrogen and helium, the two most abundant elements in the universe. This composition is remarkably similar to that of the Sun and other stars, which are also composed largely of these same elements. Hydrogen and helium were the first elements formed after the Big Bang, and they make up the majority of baryonic matter in the universe. Nuclear fusion is the process by which stars, including the Sun, produce their energy. It occurs when temperatures and pressures in the core of a star are high enough to allow hydrogen to fuse into helium. Although Jupiter and Saturn are composed of the same elements, they do not meet the necessary criteria in terms of internal mass and pressure to initiate and sustain nuclear fusion reactions. For nuclear fusion to occur, a star must have a mass of at least 8% of that of the Sun, which is well beyond the mass of Jupiter, the most massive of the planets, which represents around 0.1% of solar mass. Despite their inability to trigger nuclear fusion, Jupiter and Saturn are planetary behemoths. Jupiter is the largest planet in the solar system, with a diameter more than 11 times that of the Earth, while Saturn is not far behind. Their large size and gaseous composition mean that they have relatively low densities. In fact, Saturn has an average density lower than that of water. Unlike telluric planets like Earth, which have solid surfaces, Jupiter and Saturn have no clearly defined solid surface. Their surface is made up of dense layers of gas that become progressively hotter and denser as they descend towards the core. A dive into these planets would be a descent through increasingly dense layers of gas, with temperatures and pressures rising to levels far beyond those found on Earth. As we penetrate deeper into gas giants, we encounter more extreme conditions. Although these planets have no solid surface, Their inner layers exert colossal pressures and temperatures. These conditions can lead to the formation of seas of metallic hydrogen, a state of hydrogen under such intense pressure that it adopts electrical and thermal properties similar to those of metals. This hydrogen phase contributes to the strong magnetic field of these planets, particularly Jupiter. These planets have received very few visits. Only 8 probes have left the inner solar system. They have taught us a great deal about these gas giants, but there is still much to discover. Every little discovery raises new questions. Saturn's rings, which look uniform from Earth, are actually a sea of ice chunks dancing around the planet. The Voyager 1 and 2 probes made it possible to observe this phenomenon. Voyager 2 was the first and only probe to fly over Uranus and Neptune. Launched in 1977, they benefited from the gravitational assistance of Jupiter and Saturn. Tested in the 1970s, the mastery of gravitational assistance took off with the Pioneer 10 and 11 probes, followed by Voyager 1 and 2. These 4 probes enabled us to discover the furrows in Saturn's rings, Jupiter's turbulent atmosphere, and the first resolved images of Uranus and Neptune. Gravitational assist is the process of using the attraction of a celestial body to modify the direction and speed of a spacecraft's trajectory. Specialists calculate the probe's trajectory so that it passes as close to the planet as possible without crashing into it. It's as if the planet served as springboards for the probes. Without it, the probes would have to carry a colossal amount of fuel, making any mission impossible. The most spectacular example is Voyager 2. Taking advantage of an optimal alignment of the 4 outer planets, the probe launched at just the right speed during a launch window took advantage of the Earth's rotation speed around the Sun to reach Jupiter in 2 years. And that's not all. As it reaches the right speed to accelerate and change direction, so as to find itself on Saturn's trajectory 18 months later, 4.5 years later, it reached the trajectory of Uranus. This gives it the impetus it needs to find itself in the path of Neptune 3.5 years later. What a long and fascinating journey. As luck would have it, the alignment of the planets required for such a ballet only occurs every 176 years. Voyager 1 and 2 continue their journey to infinity today. Only Jupiter and Saturn have been the subject of dedicated missions, with 3 probes in orbit: Galileo, Juno, and Cassini-Huygens. These 3 probes have provided us with a wealth of information on the gaseous planets. Galileo disintegrated in Jupiter's atmosphere on September 21, 2003. This programmed end by NASA prevents it from polluting the moon Europa that we want to study. Cassini plunged into Saturn's atmosphere and disintegrated there in September 2017 for lack of fuel. Huygens stopped transmitting data after landing on Titan. Only Juno orbits Jupiter today. The probe arrived in 2017, revealing Jupiter's detailed appearance. Let's explore this first gas planet. Jupiter is the largest of the gaseous planets and the closest to the Sun. It lies around 778 million kilometers, or 480 million miles from the Sun. The Earth, by comparison, is 150 million kilometers or 93 million miles from the Sun. Its period of revolution around the Sun is almost 12 years. It is the largest of the planets, but it is also twice as heavy as all the other planets in the solar system combined. It alone accounts for over 70% of the mass orbiting the Sun. In Roman mythology, Jupiter is the master of the gods ruling the sky, light, lightning, and thunder. Jupiter is enormous with a diameter of 143,000 kilometers, or 89,000 miles. It could hold 1,300 times the size of the Earth. Galileo was the first to observe it in detail in 1610. When viewed from space, all we see are white cloud bands against a background of orange, red, or beige atmosphere, parallel to the planet's equator. These are gaseous masses dragged along by the planet's rotation. Jupiter's cloud bands, visible as stripes parallel to the equator, are the result of the planet's atmospheric circulation. These bands are classified into zones, light bands, and belts, dark bands, with zones representing regions of rising hotter gases and belts indicating descending colder gases. This alternation is a direct consequence of Jupiter's rapid rotation, which completes one revolution on itself in around 10 hours, creating enormous Coriolis forces that shape atmospheric circulation. The chemical composition of Jupiter's atmosphere plays a crucial role in its coloring. Although it is mainly composed of hydrogen, around 90%, and helium, around 10%, it is traces of compounds such as methane, ammonia, as well as various sulfur and phosphorus-containing compounds that contribute to its varied colors. Methane, for example, absorbs light in the red and infrared, contributing to blue and green hues. Color variations between bands can also be attributed to differences in chemical composition, cloud particle size, and cloud altitude. Jupiter's atmosphere, with an impressive thickness of 5,000 kilometers or 3,100 miles, is extremely deep compared with that of the Earth. This depth allows the existence of several layers of clouds, composed mainly of ammonia, ammonium sulfide, and water, located at different altitudes. Pressure and temperature increase with depth, leading to the formation of metallic hydrogen in the deepest layers of the atmosphere, a key component of Jupiter's powerful magnetic field. Jupiter's atmosphere is the scene of extreme weather phenomena, the most famous of which is the Great Red Spot, a gigantic anticyclone 3 times the size of the Earth, observed for over 300 years. Storms on Jupiter can reach speeds of several hundred kilometers per hour, testifying to the dynamic energy and complex processes at work in its atmosphere. The Great Red Spot has been spinning for at least 100,000 years. Today, it is 15,000 meters or 50,000 feet long and 13,000 kilometers or 8,000 miles wide. On Jupiter, the equatorial bands circulate horizontally, while the matter circulates vertically. This generates winds of up to 600 kilometers per hour, or 370 miles per hour, and creates gigantic vortices. If by magic an observer were to penetrate this planet's atmosphere, paleontologists believe he or she would sink without encountering any limits through a thick layer of gas, mainly hydrogen. Then, without transition, it would pass through fluid layers, as if the air were gradually being transformed into water. In reality, it's liquid hydrogen and helium. Our visitor would eventually reach, at a depth of 57,000 kilometers or 35,000 miles, a hard layer, the planet's core, a tiny seed at the heart of this giant. This core would be almost twice the diameter of the Earth's, at least 10 times more massive, and above all extremely hot. It would reach 30,000 degrees Celsius or 54,000 degrees Fahrenheit. Like all gaseous planets, Jupiter has a ring system. Revealed by the Pioneer 10 probe in 1974, they are so tenuous that they are only visible against the light. Due to the planet's gravitational influence, the particles have coalesced into a very thin disk. This ring system, photographed by Voyager, seems to be fed by dust from Jupiter's closest satellites. But where do they come from? These rings are very thin, very fine-grained, and very close to the planet. The most likely scenario for their origin suggests that they are made of material that was not used to form the planet's hard core. As these blocks of rock are too close to the planet, they are under its influence and have not been able to agglomerate to form a satellite. These rings appear to be totally stable. They are unlikely to evolve over the coming millennia. Jupiter has a host of satellites, at least 95, of which 57 have been given official names. The astronomer Galileo discovered 4 of them, visible through a telescope, which is why they are called Galilean. This discovery proved that not all bodies revolved around the Earth, and helped place the Sun in its rightful place, at the center of the universe. He observed them at length when he discovered Jupiter, using an astronomical telescope he had built. Let me introduce them to you. The closest Galileo moon to Jupiter is Io. Its diameter is 3,642 kilometers, or 2,300 miles. Its distance from Jupiter is 422,000 kilometers, or 260,000 miles. Its period of revolution around Jupiter is 1.8 days. From a distance, it looks like a white, yellow, and orange marble. Some astronomers call it a pizza. Its volcanism is very active. Images taken by the Voyager and Galileo probes show numerous sulfurous eruptions. Up to 300 volcanic vents have been recorded. An image of Io shows the Pele geyser spewing jets of sulfuric acid. The surrounding plains are marked by yellow, red, orange, or black sulfur flows, depending on the temperature at which the sulfur has solidified. This would be due to the strong influence of Jupiter and Europa. The 2 neighboring bodies are said to cause intense tidal forces, upsetting the satellite's equilibrium. Its surface is very young, as evidenced by the absence of meteorite craters. Deep down, its matter is molten. The day will come when Io will cross Jupiter's Roche limit. This is the zone where the planet's gravitational pull breaks everything apart. Io will then be destroyed, and its debris will form rings similar to those of Saturn. Next comes Europa. Its diameter is 3,130 kilometers, or 2,000 miles. Its distance from the planet is 671,000 kilometers, or 415,000 miles. Its period of revolution around Jupiter is 3.5 days. Europa is the smoothest body in the solar system. This Jovian satellite has a surface as smooth as a billiard ball. When meteorites smash into its frozen surface, they release a lava of water that solidifies, erasing all traces of the impact. It's all covered in ice, under which an ocean could exist. Next comes Ganymede. With a diameter of 5,260 kilometers, or 3,300 miles, it is the largest satellite in the solar system. Its distance from the planet is 1 million kilometers, or 620,000 miles. Its period of revolution is 7.2 days. Analysis of its soil reveals highly complex geological activity, with terrains of different ages. Finally, Callisto. Its diameter is 4,800 kilometers, 3,000 miles. Its distance from the planet is 1.8 million kilometers, or 1.1 million miles. Its period of revolution is 16.7 days. This icy body features numerous impact craters, including a gigantic circular structure 600 kilometers, or 370 miles long, called Valhalla. It was formed by an asteroid collision. Its subsoil is said to contain an ocean of salt water. Technological advances have enabled us to identify ever smaller objects and to count at least 95 Jovian companions. But the situation evolves regularly. With each new technological step in the precision and range of tools, new, even smaller objects are spotted. The Galileo probe plunged as far as 160 kilometers, or 100 miles, into the interior of Jupiter, i.e., less than 0.2% of its radius, before being destroyed by the extreme conditions of temperature and pressure. Scientists are still assiduously studying Jupiter, as there is still much to discover. In May 2020, thanks to the Gemini telescope, located in Hawaii, they succeeded in capturing the smallest details ever seen from the ground in its atmosphere in infrared light. In August 2022, the James Webb Space Telescope delivered another unprecedented infrared image. It reveals mists and auroras on Jupiter's surface. NASA's Juno spacecraft is currently orbiting the planet. Thanks to Juno, we know that water accounts for 0.25% of the molecules in Jupiter's warm atmosphere at its equator. On April 14, 2023, ESA launched an ambitious mission. Jupiter Icy Moon Explorer, or JUICE, is due to reach its destination in 2031. It will explore 3 of Jupiter's satellites, Callisto, Europa, and Ganymede. They are suspected of harboring an ocean beneath an icy crust. Let's continue our journey with the second closest gaseous planet to the Sun, Saturn. We know it best for its complex ring system, the most extensive in the solar system. When Galileo first saw them, he was unable to identify them. In his early sketches, Saturn appears to have 2 large ears. Before Galileo, the first to observe the planet, was the Gallo-Roman astronomer Ptolemy in the 2nd century. He identified it as a wandering star due to its slow evolution around the Sun. It is named after Saturn, the Roman god of time. This god guided men and taught them how to use the tools needed to work the Earth. It lies 1.4 billion kilometers, or 900 million miles from the Sun. Its diameter is 120,000 kilometers, or 75,000 miles. This beautiful planet has cloud layers similar to those of Jupiter. Its pale yellow hue comes from ice crystals composed of a chemical called ammonia in the upper atmosphere. One of its distinctive features is the Great White Spot. This is a storm in Saturn's northern hemisphere that occurs periodically, about every 30 years. It can extend over thousands of kilometers or miles and lasts for several months. Saturn has Aurora Borealis in the north and Aurora Australis in the south, caused by the interaction between charged particles in the solar wind and Saturn's magnetic field. Like its neighbor Jupiter, Saturn has a small core. This core is probably made up of a mixture of molten rock and metal. It has a temperature of 11,700 degrees Celsius, or 21,000 degrees Fahrenheit, and a diameter of around 25,000 kilometers, or 16,000 miles, twice that of our Earth. A layer of metallic hydrogen and helium, 10,000 to 12,000 kilometers, or 6,200 to 7,500 miles thick, surrounds this core. The layer is itself surrounded by another 5,000 kilometers, or 3,100 miles thick, made up of metallic hydrogen and helium, whose drops rain down towards the center of the planet. All this is surrounded by a third layer, 3,000 kilometers, or 1,900 miles thick, made up of 93% molecular hydrogen and 7% helium. To this must be added a little carbon, oxygen, metals, and nitrogen, the proportions of which have yet to be defined. These very high temperatures and pressures make hydrogen an electrical conductor, generating a powerful magnetic field 500 times greater than that of the Earth. Saturn is characterized by low density. Immersed in a bathtub its size, it would float. It also has an internal energy source 1.76 times more intense than the solar radiation absorbed by the planet. Its rotation, almost identical to that of Jupiter, stretches cloud formations into colored bands parallel to its equator. Its rotation period is 10 hours, 39 minutes, and 24 seconds. Its period of revolution exceeds 29 Earth years. Its axis of rotation is inclined at 26.7 degrees, giving rise to seasonal variations as on Earth. A Saturnian season lasts 7.5 Earth years. Saturn has an eccentric, elongated trajectory, which means that when it is closest to the Sun, its atmosphere is the site of storms, with winds of up to 2,000 kilometers per hour. These storms occur approximately every 30 years. So Saturn didn't have big ears. It was in 1659 that astronomer Huygens described these structures as a rigid, hard layer of matter. In 1785, the astronomer Laplace asserted that this structure, like a hoop, must be rotating to be able to maintain itself around the planet. In 1857, it was discovered that this ring was made up of a multitude of small objects, boulders or meteorites, moving in independent orbits. These objects vary in diameter from a few centimeters to a few meters, and some are the size of buildings. In 1848, Edward Roche discovered that there was a distance between a body and a planet below which the body could only be deformed and explode. That's why the blocks that make up the rings can't agglomerate into larger bodies. They're too close to Saturn. This distance is called the Roche limit after its inventor. Since the 1970s, our knowledge has evolved thanks to repeated visits by probes such as Pioneer, Voyager, Galileo, and Cassini. Cassini orbited the planet for 13 years, from 2004 to 2017. It will take several decades to exploit the data collected. The structure of these rings is extremely complex. 3 large bracelets are easily distinguishable, themselves made up of dozens of tangled rings. No boundaries are really visible between these bracelets, which are nonetheless distinguished by differences in particle density. Another astonishing feature of these rings is their thinness. Their thickness is less than a kilometer, whereas they extend to more than 300,000 kilometers, or 185,000 miles from Saturn's center. Reduced to the size of a soccer pitch, they would be thinner than cigarette paper, yet their combined mass is equal to that of a small planet. Between these rings are what are known as shepherd satellites. Like good shepherd's dogs, they bring back any blocks that try to escape. They don't show their fangs, but use their gravitational influence. The rings are named in alphabetical order, from A to G. The closest to the planet is the D ring, made up of ice particles and dust. The B ring, made of ice and water, is the brightest. The Phoebe ring takes its name from the eponymous satellite whose dust it collects. In addition to its rings, Saturn has numerous satellites, including Titan, an enormous moon with similarities to our Earth. Titan's diameter is 5,150 kilometers, or 3,200 miles, or 1.5 times that of the Moon. Its period of revolution around Saturn is almost 16 days. Titan alone accounts for 96% of the mass orbiting the planet. It is massive enough to retain an atmosphere. This atmosphere, composed of nitrogen and methane, gives Titan a beautiful orange color. On October 15, 1997, the Cassini orbiter was launched from an American rocket. On board was Huygens, a European probe measuring 2.7 meters in diameter and weighing 350 kilograms, or 770 pounds. Huygens, for whom the model is named, was a Dutch astronomer who discovered 4 of Saturn's satellites: Iapetus in 1671, Rhea in 1672, Tethys and Dione in 1684. The Cassini probe's mission is to visit Saturn and its satellite Titan. Cassini approached the planet after a 7-year, 3.5 billion kilometer journey. To get there, the probe used the gravitational assistance of Venus, Earth, and Jupiter. The latter provided the impetus needed to reach its destination. On July 1, 2004, Cassini entered orbit around Saturn. It then orbited for 4 years. In January 2005, the small Huygens module landed on Titan's surface after a 22-day voyage. It enabled us to discover the soil of this strange satellite, surrounded by a nitrogen atmosphere. The presence of methane is very important, as the cycle of this gas is similar to the water cycle on Earth. So there could be life on Titan. Now you know why we're so interested. In 2023, there are 146 satellites on Saturn, 145 of which are confirmed. The last one is awaiting confirmation. Most were discovered in the 1980s, and even after 2000. Every year, probes and telescopes enable us to count new satellites. In October 2019, we announced the discovery of 20 new satellites, observed between 2004 and 2007. This brings the total to 82. Most recently, between May 3rd and 16th, 2023, another 62 satellites were discovered. Initially named after characters, notably the Titans of Roman and then Greco-Roman mythology, their growing number has forced astronomers to draw on other mythologies. Their names define them according to their inclination. Satellites with an inclination of around 36 degrees were named after Gallic giants. We've talked a lot about Titan, but Saturn's satellites are as numerous as they are varied. Enceladus, for example, emits geysers of gas and dust, and may contain liquid water beneath its south pole. For the moment, this intense geological activity remains unexplained. Iapetus, on the other hand, is strangely bicolored. Half of its surface appears to be covered with a dark coal-like dust. For future space missions, it's not so much the planet Saturn that interests scientists, but rather its satellites. The Venus satellite, long neglected because it looks like an old rock, is currently the talk of the town. It has just been discovered that it harbors an ocean just 30 kilometers or 20 miles from its surface. This makes it all the more interesting for its potential to support life. We've also just discovered that the presence of water on Titan wasn't enough to create life. This is a disappointment for scientists, but nothing is lost. Titan is distinguished by its dense, nitrogen-rich atmosphere, as well as by its vast lakes and liquid seas on the surface, composed mainly of methane and ethane, unlike liquid water on Earth. This fundamental difference opens the door to the possibility of a totally different form of life from the one we know, one based not on water, but on methane. Methanogenic life on Titan would require a radically different biochemistry to that based on water on Earth. On our planet, water acts as a universal solvent in which the chemical reactions essential to life take place. On Titan, liquid methane could play a similar role, but with chemical reactions adapted to much lower temperatures, Titan having an average surface temperature of around -179 degrees Celsius, or -290 degrees Fahrenheit. Methanogenic life on Titan would probably involve metabolic mechanisms capable of taking advantage of the chemical energy available in its hydrocarbon-rich environment. This could include the use of compounds such as methane, ethane or other hydrocarbons, as well as atmospheric nitrogen. The exact processes remain speculative, but could involve redox reactions where hydrocarbons act as electron donors or acceptors. Terrestrial organisms use lipids to build cell membranes, creating a barrier and a stable environment for biochemical reactions. On Titan, the extremely cold conditions and methane-based environment may require entirely different types of membranes, perhaps based on molecules that remain flexible and functional at cryogenic temperatures, such as certain types of silanes or membranes composed of nitrogen-rich molecules. Directly detecting methanogenic life on Titan is a major challenge. Missions like Dragonfly, a helicopter drone scheduled to leave Earth in 2028 by NASA to explore Titan 6 years later in 2034, aim to study its complex chemistry, hydrocarbon lakes, and potentially signs of biological or prebiotic processes. However, identifying concrete evidence of life will require a thorough understanding of abiotic chemical processes on Titan to clearly distinguish between complex organic chemistry and biological activity. The possibility of methanogenic life on Titan could have profound implications for our understanding of life in the universe. It would suggest that life could exist in environments considerably different from those on Earth, greatly expanding the range of potential habitats where life could be found. It would also challenge our conception of life and the conditions necessary for its development, highlighting the incredible adaptability of biological processes. This year, NASA is putting the finishing touches to another project, a robot that moves like a snake and is therefore able to negotiate all types of terrain. Called EELS, Exobiology Extant Life Surveyor, it could be sent to Enceladus. The trip would take 12 years. Until 1781, the solar system was thought to be limited to 6 planets. At that time, William Herschel, a music teacher with a passion for astronomy, began building ever larger telescopes. His record? A giant telescope with a diameter of 1.2 meters, or 4 feet, with which he discovered a new planet in March 1781. Can you guess? It's Uranus. Initially considered a comet, it acquired the title of planet in 1783. Its name comes from that of Saturn's father, called Uranus by the Greeks. Along with Neptune, Saturn is the only icy giant planet in our solar system. Mainly composed of hydrogen and methane, this giant planet has a rocky core with a temperature approaching 7,000 degrees Celsius, or 12,600 degrees Fahrenheit. Its diameter is 51,000 kilometers, or 32,000 miles. Its mass is 14.5 times that of the Earth, and it is 4 times larger. It lies about 2.8 billion kilometers, 1.7 billion miles from the Sun. A day on Neptune lasts 17 hours and 1 year 84 years. It holds the record for the coldest atmosphere, reaching minus 210 degrees Celsius or minus 346 degrees Fahrenheit. Its magnetic field is similar to that of the Earth. It has a curious peculiarity. It is literally lying on its trajectory. While other planets spin like tops, Uranus rolls like a ball in the plane of its orbit. As a result, each of Uranus's poles faces the Sun for 42 years at a time. It is thought that when Uranus was young, it was hit by a large celestial body, which caused it to tilt. Some call it the planet in bed. The temperature differences between its light and dark sides create a very strange meteorology. When we look at it, we see a large ball with a blue-green hue, rather faded. This pallor distinguishes it from the darker Neptune. This strange color is probably due to the presence of methane in its atmosphere. Methane absorbs red light in the solar spectrum and reflects blue light, giving Uranus its characteristic hue. But methane alone cannot be responsible for Uranus's characteristic color. If there were only methane, Uranus would be blue like Neptune. Scientists speculate that an unknown gas, a mysterious compound, may contribute to this particular shade of blue-green. At its center is a core of silicate rock, iron and nickel, slightly smaller than that of the Earth. This core is surrounded by a mantle of volatile components called ices, despite their state between liquid and solid. This mantle is around 10,000 kilometers, or 6,200 miles thick. The components are water, ammonia, and methane. All this is enveloped in an atmosphere composed of 83% hydrogen, 15% helium, and 2% methane. The icy giants have a mass well below that of Saturn or Jupiter, but represent 15 to 17 Earth masses. Only 20% of this mass is hydrogen, whereas on Saturn, hydrogen accounts for 90% of the mass. Much of Uranus's mass is stored in its ices. Uranus has only been visited once, by Voyager 2 in 1986. The flyby lasted 5 hours and 30 minutes, just 80,000 kilometers or 50,000 miles from the planet. The probe was also able to observe the planet's rings. Uranus has 13 dark-colored rings. They represent the second ring system discovered after that of Saturn. Composed of minerals such as carbon, they are very thin and narrow, less than 30 kilometers or 20 miles thick. The Hubble Space Telescope revealed the two outermost rings in 2007, when the planet tilted in such a way that from the Earth its rings overlapped. The first rings were discovered in 1977. The rocks making up the rings contain little dust and consist mainly of boulders, 0.2 to 20 meters, or 0.6 to 65 feet in diameter. The rings are named Zeta, Alpha, Beta, Eta, Gamma, Delta, Lambda, Epsilon, Nu, Mu, and 654. Mu, the furthest ring from Uranus, has a lovely blue color. The same is true of Saturn's outermost ring. Both rings have moons, Uranus's Mab and Saturn's Enceladus. Astronomers believe that these satellites act as filters, capturing the ring's larger particles while allowing smaller ones to pass through. These particles, smaller than a micron, are thought to diffuse blue light. The Nu ring, close to Mu, has a beautiful red color. Uranus has 28 known natural satellites. They are named after characters in the works of William Shakespeare and Alexander Pope. The 5 major satellites of Uranus are Titania, Oberon, Miranda, Ariel, and Umbriel. William Herschel discovered the first 2 in 1787, 6 years after Uranus. William Lassell discovered Ariel and Umbriel in 1851, and Gerard Kuiper discovered Miranda in 1948. The other moons were discovered by Voyager 2 in 1985, and others by ground-based telescopes. The satellites have sufficient mass to be in hydrostatic equilibrium, i.e. stable in size and surface. 4 of them show signs of surface activity, such as the formation of canyons or volcanism. Uranus's largest satellite, Titania, is the 8th largest in the solar system, with a diameter of 1,578 kilometers, or 980 miles. According to a Japanese study published in 2020, the satellites of Uranus were formed by the impact of a body with the planet. This impact produced a disk of vapor, which condensed and produced ice particles. These particles would have formed the satellites by accretion. All of Uranus's major moons are composed of equal parts of rock and ice, except Miranda, which is essentially composed of ice. This ice may contain ammonia and carbon dioxide. In 2024, 10 irregular satellites are known to orbit Uranus. Their orbit is beyond that of Oberon. For the past 30 years, Uranus has not been one of NASA's priority missions, but things are about to change. In April 2022, the U.S. Space Agency unveiled its next missions for Uranus, Uranus Orbiter and Probe. Launch is scheduled for 2031. It will be 2044 before the expedition's probe orbits the planet, enabling new discoveries to be made. It will study the structure and origins of the planet, as well as the nature and formation process of its rings. Astronomers have high hopes for this expedition, as the planet is still the subject of many questions. Let's move on to the last gas planet, Neptune, the furthest from the Sun. Remember that the discovery of Uranus set tongues wagging. We weren't expecting it. By observing it closely, astronomers of the time realized that it wasn't turning as it should. Something was disrupting its trajectory, and that something might well be a planet. A race was on to find this invisible star first. While some of his colleagues scanned the sky, the Frenchman Urbain Le Verrier chose another method, calculation. By studying the perturbations in Uranus's motion, he tried to predict on paper where the new planet should be. In September 1846, he indicated its probable position to the German Johann Galle, who found the planet that very evening. For the first time, calculation was ahead of observation. After some debate, the new planet was named Neptune, a mythological name in harmony with the names of the other planets. Far more distant than Uranus, Neptune is nevertheless better known to us thanks to the Voyager 2 probe, which sent us some superb photographs in 1989. Neptune has a beautiful blue color. This is due to atmospheric layers rich in methane. With a diameter of 50,000 kilometers or 30,000 miles, Neptune is the smallest of our four gas giants. Its mass is 17.2 times that of the Earth, making it the third most massive planet in the solar system. This is 1/19th the mass of Jupiter. Neptune is the densest giant planet in the solar system. Its distance from the Sun is 4.5 billion kilometers, or 2.9 billion miles. A Neptunian year is 165 years long, and one day lasts 16 hours. Like Jupiter, it has a huge permanent cyclonic formation. It features a white secondary cyclone, which scientists have nicknamed the Scooter because of its speed. In the planet's southern hemisphere, Voyager 2 observed a large black spot, which appears to be similar in every way to Jupiter's red spot. Its origin is different, however, as a strong magnetic field is suspected. Neptunian meteorology is thought to be turbulent, as a comparison of images taken by the Hubble telescope in 1994 and those taken by Voyager 2 in 1989 reveals numerous differences. Some spots have disappeared, while new ones have appeared. The Great Black Spot no longer exists. Neptune's internal structure is similar to that of Uranus. It probably has a solid core of iron, nickel, and silicates. The pressure at the center would be twice as high as at the center of the Earth, and the temperature would be around 7,800 degrees Celsius, or 14,000 degrees Fahrenheit. Above this core, it could have a fairly uniform composition of different ices, hydrogen and helium. This sets it apart from Jupiter or Saturn, which have a layered structure. The internal structure of Uranus and Neptune is often modeled in three main layers. One, in the center, a rocky core of silicates and metals, similar in composition to the telluric planets, but much more massive. Two, surrounding the core is a thick layer of water, methane, and ammonia. However, the term ice does not refer to the solid state of these compounds as they would be on Earth, at 0 degrees Celsius or 32 degrees Fahrenheit. Under the extreme conditions of pressure and temperature found at this depth, these substances form a dense warm fluid, sometimes called hot ice or fluid ice. This phase is different from that of liquids or solids encountered in more familiar terrestrial conditions. 3. The outermost layer is a thick atmosphere composed mainly of hydrogen and helium, with a small amount of methane contributing to the characteristic blue-green color of these planets. This atmosphere extends over 8,000 kilometers, or 5,000 miles in thickness. It is this internal structure that is important in understanding why Uranus and Neptune are not simply smaller versions of Jupiter and Saturn. Differences in their composition and internal structure suggest different formation processes or varying initial conditions within the protoplanetary disk that gave birth to the solar system. Its internal heat is sufficient to generate planetary winds of up to 2,000 kilometers per hour, or 1,200 miles per hour, the fastest in the solar system. Neptune's temperature is far from stable. Variations of several degrees have been observed from one year to the next. Let's talk about another curiosity specific to Neptune and Uranus, diamond showers. For some years now, there has been a hypothesis circulating that diamonds are raining down from the heart of Neptune. But how is this possible? Scientists at Stanford University have reproduced Neptune's extreme conditions in the laboratory. They used polystyrene instead of methane and sprayed it with an optical laser. They observed a separation of hydrogen and carbon. The hydrogen escaped and the carbon was transformed into diamonds. These diamonds would flow towards the center of the planet rather than raining down on it. A dream come true, don't you think? Neptune is surrounded by a system of 5 rings, some of which display very bright concentrations of matter. These rings were discovered indirectly in 1984 from Chile. At first, they were thought to be incomplete, but Voyager 2's passage allowed us to see them in their entirety. By observing Neptune's passage in front of a star from Earth, we can make out their presence. They are dark, and their composition and origin are still poorly understood. One of them, called Adams, has 4 arches nicknamed Liberté, Égalité, Fraternité, and Courage. These arches are actually brighter parts of the ring. Scientists believe that these arcs are locked into their shape by the effects of the moon, Galatea. Some of them are twisted, but we can't yet explain this phenomenon. The 3 main rings are Gal, located 42,000 kilometers, or 26,000 miles from Neptune's center, followed by Leverrier and Adams. Lassell is a weak extension of the Leverrier ring. The latter is bounded by Arago. Leverrier, Arago, and Adams are narrow, around 100 kilometers or 62 miles wide. Gal and Lassell, on the other hand, are very wide, between 2,000 and 5,000 kilometers, or 1,200 and 3,100 miles wide. These rings are thought to be young, formed after the solar system. Neptune has 16 confirmed satellites. As Neptune is the Roman god of the sea, its satellites are named after lesser marine gods. Triton, discovered in 1846, is a large satellite 2,700 kilometers in diameter. It is therefore larger than Pluto. It orbits some 355,000 kilometers, or 220,000 miles from the planet. Volcanic, it spews out plumes of ice. This activity regularly modifies its surface, making it the second youngest planet in the solar system. Strangely, it orbits the planet in the opposite direction to all the other satellites. This peculiar motion suggests that it is a former dwarf planet reclaimed by Neptune. It will eventually break up when it reaches the Roche limit in 3.6 billion years' time, forming rings similar to those of Saturn. Nereid, the most distant, was discovered in 1949. It has one of the most eccentric orbits in the solar system. Larissa was discovered in 1981. Photos transmitted by Voyager 2 led to the discovery of Naiad, Thalassa, Despina, Galatea, and Proteus in 1989. 5 new moons were discovered between 2002 and 2007. Finally, in 2013, Hippocampus was discovered by combining several Hubble images. It is the smallest moon known to date. Like Uranus and Jupiter, Neptune also has Trojan asteroids, sharing its orbit around the Sun. Many projects have been abandoned in recent years. One proposal is currently underway through the Discovery program. The Triton probe would make a flyby of Triton and Neptune in 2038. A single flyby is planned, during which the data acquired should make it possible to determine whether the underground ocean predicted by the models is indeed present, and therefore whether this moon is potentially habitable. In 2030, the alignment of Uranus and Neptune would favor a space mission to these planets. But 2030 in astronomy is tomorrow. Such an important mission requires a lot of time and money. The European Space Agency has already announced that it will not be ready before 2050. Only NASA has the time to work on such a project. Otherwise, we'll have to wait until 2040 for the next alignment. The study of these planets has another major interest: understanding exoplanets of similar size. Around 40% of known exoplanets are the size of an ice giant. In 2010, researchers proved that a Jupiter-sized gas giant had survived the death of its host star. In 2000, researchers discovered the planet Osiris, 150 light-years away, in the constellation Pegasus. Its official name is HD 209458b. This gaseous planet resembles Jupiter in composition, but orbits much closer to its star than Jupiter does to the Sun. It is therefore much hotter. It is so close to its star that all its gas could evaporate within a few million years. All that would remain would be its solid core. This phenomenon would give rise to new planets, Chthonian planets, the planetary remnants of former gas giants. As you can see, there are several scenarios for the future of our gas planets. Now we come to the final point of our journey. We're leaving our solar system.